Good morning, everyone. You know, Lawrence, the work that you've done to bring together a real global voice around the issues that we're trying to tackle is incredible. You've done a fantastic job, and I just want to recognize that. Tom, really, your comments were spot on. So I want to say a few words, kind of some of my thoughts about the topic today around electrification. So as a little bit of background, I'm Mike Howard, President and CEO of the Electric Power Research Institute. And for those that are not familiar with EPRI, we're a global organization really focused on science and technology. One of the things that I like to say is we help to accelerate the technical and solutions to many of the challenges that we face here. We're a global organization. We have operations in many countries, and many of you we work with. So we're focused on everything from the generation of electricity to the delivery of electricity, and then certainly the customer and how the customer uses cleaner electricity. So in thinking about this discussion, I wanted to go back a little ways. And I started thinking about, you know, the first, how far we've come in almost 2 centuries. The first electric motor was developed 185 years ago. 185 years ago, first electric motor. Transformer 141 years ago. The transistor 72 years ago. The microprocessor 51 years ago. Power electronics 40 years ago. All of those technologies are fundamental to what we're talking about today. And the work that we're talking about today, the innovations that we're talking about, are built on the shoulders of all of those individuals that were critical in better understanding how we can use electricity. I like to say that electricity is a very precious, high-grade form of energy, and it's growing. In the U.S., 21% of our total energy is electricity. Globally, it's about 19%. In all of the scenarios that we look at, including scenarios from IEA and the U.S. Department of Energy's EIA, all project that as we go forward, the percent of electricity as a percent of overall energy is increasing. Various scenarios that show that when you go out to 2050, it could be as much as 50% total electricity of total energy. In the U.S., again, it's about 21% right now. Globally, it's about 19%. Electricity is a very precious and high-grade form of energy. And it is built on the innovations that have occurred for almost 2 centuries. All right. Now we're going to look forward. I went and looked at the posters. They're incredible. I mean, there are some really cool, as a technologist, there are some cool technology projections there. One of the things that we're going to do today is I've talked with our panelists. Well, they're going to briefly introduce themselves and have a chance to talk a little bit about some of the things that they're doing. We have 3 of the individuals are focused on the poles, the wires, and the pipes side of the business, and one is focused more on the generation side. So we've got a very diverse, geographical diverse panel and technology diverse panel. So some really good discussions that we're going to have today. But I also asked the panelists to think about a bold projection. Think about electrification in the future and some bold projections. Now, for electricity to continue to be a precious commodity, it will have to get cleaner. And we're doing a really good job there. But there's more and more technologies around, in fact, we'll hear about some of those, around enabling electricity to be cleaner. Technologies that will enable that cleaner electricity to be delivered. And then a growing number of technologies that will allow us as consumers to use electricity in ways that we never imagined. And we're going to talk about that. And we're going to talk about some bold projections about the future. Now, this is not only a discussion with a panel, it's also a discussion with you. So think about your questions. Think about your bold projections. If we don't hear any, I'm going to ask you. We're going to turn this around, and I'll start asking each of you for your bold projections. And so we want the projections to be, certainly bold, technically feasible, but kind of out there. Because we want to kind of frame this in a perspective of what's possible. We know certain things. We know electricity is very precious, a high-grade form of energy, and is not going away. We know that it's only going to expand in terms of how important it is globally. We know that we want to continue to focus on electricity being safe, certainly reliable, affordable, and cleaner. Those are the things we know. And we want to focus globally on advancing technology that will enable that to even accelerate. So that's what we're going to be talking about today. Any questions before we get started? I'm excited about this discussion. There are some really cool technologies that are out there. EPRI is working on several of those, working with several of you, universities, national labs, and on and on. And I could not be more excited about the future of electricity. It is getting cleaner, and we're finding all kinds of ways to use it to enable the prosperity of society globally. So with that, let me go ahead and kick it off to Ty. Go ahead, and then we'll just kind of march on down the line, and then we'll come back and we'll start having a discussion. Thank you and good morning.
Thanks, Mike. I thought you were going to start at the other end, so thanks. No,
Okay.
all good, mate, as we say in Australia. Good morning, everybody. My name's Ty, General Manager Asset Management from a company called Endeavour Energy. You may or may not have heard about us. We're a poles and wires business, those poles, wires and pipes we were talking about earlier. We supply an area that's all of the Sydney surrounds, but not the actual core CBD of Sydney in Australia, which is the largest city. We're the third largest poles and wires business in the country. But importantly, one of the big challenges we face is serving the growth in Australia's largest city. We're currently in the process at the moment of supplying energy to a completely new greenfield city surrounding the second airport that's going in and around Sydney. We've got a very unique opportunity, not just to use digitisation to manage an existing asset base, which I'll talk more about briefly in a moment, but also to use those same techniques to be part of the process to stand up effectively a greenfield city of 250,000 people or more. The current residents of the land occupied by that eat grass and walk around and say moo. So it's really going from one end of the energy demand and infrastructure spectrum to the other in a single step, and that's over the next 5 to 10 years. We're looking for that city to be created. So we've got quite a unique opportunity that we see to build in from the outset to the whole energy supply ecosystem and dynamic. A lot of the digital techniques and much of the new technology that we've traditionally as an industry, I think, had to retrofit to an existing built environment. So speaking briefly, and this is apologies if this is repeating some things for those who were part of the proceedings yesterday. What Endeavour Energy has been doing at the moment is we've created a digital 3D network model of our entire above ground network. That's allowed us to replicate entirely the above ground assets on a desktop environment. You can fly into that, fly around it literally. It captures everything from the built environment to the interaction with our electricity assets. And for me, this has been part of the journey that we've got of, I'm not going to presume to speak for the industry globally, but certainly within Australia, within my country, we've traditionally been in the poles and wires area business that I describe as having our eyeballs in the tips of our fingers. In that the only people who really knew the data and really knew and understood with a deepness and a richness the assets that we're managing to serve customers here are the people who are out there interacting with it on a minute-by-minute basis. But the creation of a digital model and bringing that more into the office environment, we've found to be transformational in terms of allowing us to understand at the strategic level what's actually going on out there and what our assets are doing. We've managed in doing that then to start mining the data that it's created. We've like California, the climate in Australia and in particular in the area that we serve is very similar and very prone. We call them bushfires. In North America, they call them wildfires, I believe. Looking for a nodding head somewhere there. Yeah, thank you. I'll pay you later for that one. And this is the greatest single risk that we face and our customers face in managing the interaction between the natural environment and our assets. Using digital modelling techniques as a business, we've been able to risk profile each individual span out there on our network, around 500,000 of them, for likelihood and consequence of wildfire risk to well-established algorithms. We've been able to do that en masse and on bulk. What that's allowed us to do is place a differential risk management approach around each of those 500,000 individual spans. That's allowed us to achieve a superior risk management outcome in terms of avoiding bushfires where we can, but it's also allowed us to, within that, wash out a very significant, over 20% of our costs and of what is our largest single line item, and pass those savings back on to our customers. And all of that's occurred not from going and capturing anything more, but from more intelligently using, processing and partnering with the right sort of companies on the digital lake that's already been created of data that's out there, using it more intelligently. And as I said, I think critically, we were talking about it earlier, working with our very smart engineers within the industry and within our business, not to get them actually doing all of the smarts themselves, but to have them working on the use cases for those smarts and picking a strategic partner who can do the things that are at the leading edge of what we want to do with digital asset management better than we can, and engaging with them in a partnership sense. So I'll wrap up there, and hopefully that can simulate some questions and thinking.
Thanks very much, Ty. I'm really impressed with the work that you're doing on kind of really creating a near perfect visualization of your assets, the 3D model. That is, because once you have that capability, then you can start asking what if questions. You're better able to understand the condition of the system when it's operating perfectly, and more importantly, the condition of the system when there's an issue, like a wildfire or something else. And so sounds great. Now let's go to Kate with Capital Power and hear from Kate.
So good morning. Good morning. Good morning. Is that better? You may have noticed that I'm the only Canadian on this panel. I'm also the only IPP. I am proud to say that Capital Power is a generator. We have a wide portfolio, which includes coal, wind, solar, and biomass. We sold our run-of-river hydro a few years ago, but we've done a lot of things. And since about 2004, we've been working to make thermal generation lower carbon. And we have been working to convince people that even Canada is working towards decarbonization in 2050. 2050. And we've been working to make sure that people understand that we're not going to get to decarbonization without natural gas generation. In Canada, coal is dead now, but and so we've been taking tiny baby steps. So, for example, at the moment, while we work towards converting all of our coal units, we own all or part of 4 large coal units. We've been, and we are converting them to gas, but we're co-firing with gas in the meantime. And of course, to the extent that we have gas capacity available, that cuts the emissions in half. But moreover, we, since about 2004, we have participated in 4 different carbon capture and either sequestration or storage projects, all of which were reasonably successful technically, all of them viable. But of course, they're all pretty expensive. And in our home province, we operate in a competitive market. And so we couldn't make them work economically. However, more recently, we're working on carbon capture and usage. And we have, we think, found a way, and I shouldn't claim credit to Capital Power, because there are a lot of very, very smart people in the utility industry that are working on this right now. But we found a way to capture carbon from our flue gas, or actually from the air, but from our flue gas, and turn it into what are called carbon nanotubes. And these carbon nanotubes, I have to apologize, I'm neither an engineer nor a scientist. I'm a recovering lawyer, so please don't ask me any really hard questions. But these carbon nanotubes are lighter than aluminum, stronger than steel, and more conductive than copper. And so they are currently already being used in Kevlar vests. They were incorporated into the skin of the Dreamliner. And we are working with some cement companies to see if they can't reduce the amount of other raw products that are incorporated into cement, and which the production of creates a whole bunch of global carbon emissions. We're working really hard on this. I just want to give a shout out to Fortis. Is Jim in the room anywhere? Just to give you an example of some of the good work that other people are doing, Fortis BC owns a hotel in downtown Surrey, British Columbia, in which they are converting carbon from their exhaust into sodium bicarbonate, or baking soda. And so there is a lot of work on this. You may have read Bill Gates has recently established a pilot project for a different carbon capture and usage project in British Columbia. And so I know that CCS has a bit of a black eye in the electric industry because of its extremely expensive outcome, and because I think there are sort of nervous people around liability for escaping carbon, et cetera. But carbon capture and usage is quite different. To the extent that you can produce something that has a value to consumers, you offset the costs of the capture, and the whole process becomes quite economic. It also turns the carbon eventually into something which is completely inert and non-toxic and benign. There were some previous carbon capture and usage projects that were criticized on the basis that they were just going to delay the release. So, for example, injecting carbon straight into cement would entail releasing the carbon eventually when the cement breaks up. But some of these newer projects don't do that at all. And so I believe, for a number of reasons, and I know that I'm talking to the choir in this room, if you talk to an expert, I think it was probably around 2013 or 2014 that in Canada, at least, the public dialogue changed quite suddenly and quite violently from let's all reduce carbon emissions to let's get off fossil fuels as quickly as possible. And I think that was very well intentioned, but I think it was extremely naive because our electric systems cannot operate without gas. They absolutely cannot operate without gas. If you speak to any expert, they will tell you that an electric system can support anywhere between 50 to 80% renewables, which would be great. We also develop and operate renewables, all for that. But for example, in my home province, and you will all have your own versions of these problems, we had the coldest February this year since about 1960. And in the month of February, wind was available about 5% of the time. And so if you are building a capacity, you sort of need to overbuild in order to do all that. So there's a cost implication. But over and above that, we have done calculations, and for example, in the province of Alberta, in order to power the city of Edmonton with renewables, we would have to cover the entire province and more with solar. And that's a little known fact. Alberta actually has the second or third best solar resource in North America after the U.S. Southwest and Alaska. So, I mean, we could do that, but that's a lot of farmland gone to waste. So I look forward to speaking with you about an emission-free carbon future. Thank you.
Thanks, Kate. So at EPRI, we have been involved in various carbon capture and storage and carbon capture utilization technologies. And I appreciate what you said on that, Kate. And any projection that we look at, and this is consistent with others as well, that it is impossible to achieve what has been laid out in the Paris Agreement without some form of carbon capture and storage or utilization. We certainly will advance the technologies around renewable energy. We'll continue to advance the technologies around nuclear. But the world is still going to use fossil fuels. And that is going to require some technology around capturing that carbon and doing something with it. And so what you are doing, Kate, to help advance that technology is incredible. I know several of you are also working on that, but it has to be solved to get to the 2050 number. So appreciate that. So now let's go to National Grid and let's hear from Terry.
Thank you and good morning. I'm Terry Sobolewski. I'm the Chief Customer Officer for our U.S. business and also the president of our Rhode Island business. Some of you may know National Grid in the U.S. operates predominantly in the Northeast. We serve customers, about 20 million folks across Massachusetts, Rhode Island, and New York. And it's both a gas and electric business. About half of our customers are served with gas, about half with electricity. And as we think about technology and innovation, we are investing heavily in our system and investing heavily in the technologies that face our customers. Over the next 5 years, we'll invest more than $8 billion. And that really covers an extraordinary waterfront. That includes investments in our transmission systems, everything from digitized substations to real-time monitoring of our system. Includes investments in our distribution systems, including the deployment of AMI, again, more monitoring capability, distribution system management capabilities, and the ability to integrate more and more renewables. We've got about 1.4 gigawatts on our system now, and we expect to double that in the next 2 or 3 years. But it also includes important investments in terms of how we face off with our customers. We talked about it a bit yesterday, but we're investing in interesting technologies like personalization, being able to present to a customer their next best option for an energy choice they might make in their home or in their business. It includes some foundational things like replacing our customer information systems and implementing CRM tools. And of course, it includes the continuation of energy efficiency programs and demand response programs, programs that we're pretty proud of, some of which rate among the highest in the U.S. But today, we invest about $600 million a year with customers in technologies in their homes and businesses to reduce their energy consumption or help them be more responsive to changes in the system or how we might optimize that system. And then, of course, with customers, we're also talking a lot about electrification. We have a proposal in front of the Massachusetts DPU right now, $167 million for incremental charging. That would be an order of magnitude increase in the amount of charging infrastructure, electric vehicle charging infrastructure in the state of Massachusetts. And then lastly, we're focused on innovation and, in some cases, early stage venture capital work. We've now got a group, though I said we operate in the Northeast, we actually have an office in San Francisco. When I was told that, I was shocked. I also asked if I could move there. That didn't work out, but we have a group there under Lisa Lambert's leadership, National Grid Partners, which has already made 6 early stage investments in leading edge technology companies. They've got a rather sizable checkbook, and they're looking to make another series of investments over the next 2 or 3 years in companies that are really, I think, defining some of the leading edge capabilities that we can bring to bear as an industry in creating really extraordinary outcomes for customers. But with all that, I think at the center of it for us, anyway, is a pretty monumental shift in how we go about that investment. For a lot of years, we've been good at building stuff and earning a rate of return on that stuff. But increasingly, the development of these technologies and the implementation of these technologies really require us to take a fundamentally different approach with the customers and communities that we serve. The best example that we refer to all the time is our experience in Worcester, Massachusetts. We had the opportunity to do a smart grid pilot. And in our traditional way, we got together our best engineers. We locked them in a closet for 3 months. Out they came at the end of that with a pristine analysis of exactly how we should deploy smart metering technology and grid optimization solutions in the city of Worcester. We presented that to the city and to the DPU and said, see, look at this wonderful solution. We'd like to begin construction right away, and they threw us out. And we weren't totally sure why until we reflected on it a bit and realized that we had done nothing to engage that community. And so we went back to the drawing board. And instead of working on the solution from our point of view, we asked them what they thought would be most meaningful to help advance not just how we use energy in the city of Worcester, but other community goals that they had in terms of economic development and otherwise. We went back in with a new plan alongside of the city of Worcester, and of course that plan moved forward with great success. So what does that tell us? Tom challenged us earlier about getting on offense, and I think offense for us is really, I'd use a different word, it's inclusiveness. We really feel like as we think about this $8 billion of investment, it's $8 billion of investment that has to be done in partnership with communities. The planning for that has to be done in partnership with communities. And increasingly, the solutions we bring to bear have to be done in a way where we're really listening to what customers want. We think we have great ideas, but what we need to do is actually start with what the customer needs are and work back from there. And so in everything from our REV demonstration pilots to our internal innovation teams, we're really pushing hard to make that fundamental cultural shift within the company.
Thanks, Terry. So EPRI's headquarters is in the San Francisco Bay Area in Palo Alto, and so you are welcome anytime you want to come to the Bay Area. It's a great place. It is a great resource for hyper innovation, and it's the weather couldn't be better. So you said a couple of things, Terry, that I think is really important. You talked about energy efficiency, and you talked about electrification. At EPRI, we call it efficient electrification. And the reason we do that is because electrification is a very, very efficient use of electricity for many, many reasons. So when you electrify, you also become more efficient, whether that's electric vehicles or you name it. Many industrial processes will become much more efficient with electrification. And so we have shown that over and over and over. That has its basis in physics and certainly a variety of other technologies. And for that reason, electrification is becoming a very competitive advantage for many companies, many industries globally. So I appreciate you you highlighting that. So let's go to Nigel. Nigel is from New Zealand with Powerco, and so welcome, Nigel.
Thanks, Mike. So look, I just thought I'd share a little bit about Powerco and New Zealand's story. So we're the second largest electricity distributor, so pure poles and wires business, with a gas pipelines business as well. We do have the largest service territory, which means we have a very large regional, rural customer base that we serve. I think, when you think about New Zealand, probably a lot of you will have seen the tourism brochures, or if not, seen some Lord of the Rings. When I'm raising money in the States from US insurance companies, I have actually on one of our maps circled all the Lord of the Rings film sets that overlay our network, and that can be the longest slide we spend any time on. Great for distraction, but anyway. But what we do in terms of export dollars is we turn that visual scenery plus rain and sunshine into protein, be it red meat, white meat, or alternatively fruit. A large amount in terms of horticulture, kiwi fruit, or viticulture wine gets exported. So when we look at our challenge going ahead on the back of, rain obviously means hydro, we're 65% baseload hydro as it is, 15% geothermal, 5% wind, so we're 85% renewable with just doing nothing as it is today. But when we look at our challenges with that large, basically protein production industry that goes on, our challenge is actually methane from animals, and there's very little you can do about it. So our government, and this is generally the consensus position between left and right, is very committed to some aggressive greenhouse gas reductions. So it's not just carbon, but methane. And that means electricity is more than picking up the share. In a relative sense, New Zealand's going to go from where electricity as a percentage of total energy from all sources is around 25%, and of that, 85 is renewable, to 60% renewable in the next 30 years. So we're talking large build out. And this is where you sort of start to think about the technology in this one. The technology for us is less about optimization and sort of focusing on, that's going to be important, optimizing how we build and making the existing networks more efficient. It's actually how do we electrify entire industries that in the past, and probably in one level today, you'd say it is simply much more efficient for them to be powered by natural gas. And dairy is a good example. On our footprint, our service territories, we have probably 25% of all meat and dairy plants in New Zealand. A large dairy factory, and we have some of the New Zealand has, I think, 3 of the 4 largest in the Southern Hemisphere. And I think there's about 20 dairy factories overall. But 3 large dairy factories is the equivalent of 1 medium-sized aluminium smelter. So you're talking about converting very, very large loads where 90+% of all the energy use today comes from gas or coal. We only have gas in the North Island, so there is no ability. The dairy factories in the South Island, the meat plants in the South Island are all a coal story. So you actually start to think, running very, very large megawatt scales and tens of megawatts and scale boilers all of a sudden on electricity is only just coming out. And then you've got to try to think about how we actually make that economic. You look at coal versus electricity, the economics of that have never stood up. So you've got carbon charges, you've got policy decisions you've got coming in, and then you've got to start to weigh in, well, how are we going to achieve that? We've got to achieve that technically, both with the boilers and the transmission and distribution interconnects. You're talking about loads that have gone from basically just using electricity for the industrial process controls and lighting to suddenly 100%. The existing networks that supply them are just simply not large enough. I have, whenever I speak to school children or university level kids these days, or young people these days, I encourage them to think about electricity. Like my example I give is there will be so much copper deployed in the next 30 years, you will not be short of work. In addition to some really smart technology will go out there, but So that's sort of on the dairy side, and then we've got to get transport there. To get to these numbers, we're talking about basically the entire transport fleet, heavy haulage and light vehicle, going electric largely, and heavy haulage is going to be a more difficult play than light vehicles. But that's sort of the challenge we're looking at, and I was reflecting on it a little bit, and we've been talking to sort of our Prime Minister and other senior politicians, and there's this weighing up, or there's very delicate balancing act going on between the idealism they want to lead. This particular government really wants to lead. It really wants to set New Zealand to show by example. It really wants to embrace aggressive decarbonisation goals very quickly, roll out electrification, really try to push electric boilers and that, which is still pretty cutting edge, and particularly at the size we're talking about. While at the same time, because they're not experts in electricity, and they're looking at it going, but the solar cost curve's dropping, so that means the price of electricity is dropping. So can't we just extrapolate that as the wholesale price of the market? And for those that are involved in markets and how it works, solar's an intermittent fuel, it will not set the wholesale pool price. The wholesale pool price will be set by other stuff. The bigger power plants that you build, each one is generally going to be more expensive than the last one, so the pool price is going to edge up over time. So you've got this political gap which you're trying to manage, where they're looking at the solar cost curve going, it's dropping. Why is the wholesale pool price not going to drop when we go all electric? And you've got those of us in the industry trying to politely, without really annoying them, explain it's not quite going to work that way. But we are getting some traction, but it's about trying to balance, trying to get them less focused on, say, it has to be done this way, and more on, you set us the outcome you want in the output sense, and we'll get you there. But if you start telling us how we have to get there, that's when the price shock starts to come. So in various ways, if we can get there via, say, first cab off the ranks electrification of transport, which is going to probably be considerably cheaper than electrification of process heat. So let us tackle that cab first. We can probably get you there largely on your first tranche of goals with less than 10% wholesale price shock. We can do it reasonably sensible in that. But if you start to limit us to how we're going to get there, you're going to see much bigger shocks. So that's probably enough from me at that point.
Excellent. So, very, very good discussions. I want to, for Nigel, Ty, and Terry, and then I'm going to come back to Kate, but for Nigel, Ty, and Terry, I want to ask a question and see if you can fit it on a bumper sticker. So just a few words. And the question is, when you look out over the next 10 years, what is excuse me, the one or two biggest opportunities around electrification? And then when you go out beyond 10 years, does that change? Is there another answer you would give if it's beyond 10 years? So just kind of think about that in just a quick answer, and then we'll go down the line. You kind of touched on some of this, but I want to kind of get it confined into a bumper sticker. So, Ty?
Well, Mike, I think your bumper sticker is a very fitting way to frame this, because I think the play in the next 10 years or 0 to 10 year frame is transport, as Nigel was talking about. I think that is the next big play. I was checking the news headlines. We've got yet another election coming up in Australia, so that'll be great. We'll get a new Prime Minister probably out of that, and then 5 minutes later his party will knife him, and we'll get another one after that. That's the game in my country for some reason that evades logic and the ken of all of us in the country, but that's the way it goes. So transport is definitely going to be, it would be my summary there in terms of the 0 to 10 year play. Where does it go beyond that? Am I allowed to speak briefly about that, or would you want me to stop?
No, good.
Because it goes to your introductory question as well. My thinking on that is that energy supply for us all ceases to become the system, the traditional, dare I say, almost paternal approach that it's taken, where we look after this, we've got your back, community out there. We know what's good for you, trust us, etc., etc. But I think the play that is probably still within certainly the latter half of that time frame is all that we do. We talk about, digitisation of the network. We talk about transformation of carbon use and those sorts of things. All of that, for me, I can see it becoming overlaid with, to use too many buzzwords, I know, AI and big data type techniques. What I can see is an ecosystem there where customers either can make their own choices or more likely have apps that they use, third-party aggregators, and their whole energy supply is just integrated into their whole lifestyle supply. Their home and the home automation comes into things, likewise for businesses, and all of this just becomes a large-scale service that's probably got a lot more in common with the way the internet operates at the moment than it has anything in common with how the electricity network in all of its various layers and tiers as it stands at the moment operates. So throw that out there for an idea.
So it's transportation followed by everything else.
Pretty much.
Yeah. Terry?
Similarly, I think in the next 10 years, it's all about transportation, exponential adoption. We did an 80 by 50 pathway study. We think in the next 8 years, we have to get to, in the Northeast, 100% of light-duty vehicles sold would be electric, 50% of the inventory, but 100% of sales. So 100% of sales, exponential adoption. That's the 10-year story. I think the 20-year story is it's all about heat. And for us, where we are, this is geographically specific. I think it's going to get done with geothermal, and it's going to get done with gas system decarbonization to the tune of 20 or 30%.
Wow, that's good. Nigel?
So I was thinking about the bumper sticker first, and because my 10-year view is all about electrification of transport, this is my last V8 before it's an environmental offence. And after that, it is process heat electrification of sort of big industrial users. But within that, I think there is a subtlety as to whether we can get carbon capture and storage there in time to make it, because the cost of the electrification of them is actually massive when you think about the transmission upgrades, distribution upgrades, let alone the new boilers and rebuilding entire plants. And so I think that'll be really interesting to see how that plays out in sort of 10 to 20 type mark.
Yeah. So certainly in the next 10 years, it's all about electrification. I mean, about electric vehicles. I think that's the major focus, not only did in the U.S., but as you're really around the world. And that's all enabled by two technologies. One is power electronics and the other is energy storage. Some work that we've done shows that energy storage, energy density, so meaning more energy stored per unit weight, is increasing about 20% every 18 months. So you just run the numbers, and it's not too long until you have a battery that's not just 200 miles, 400, 500, 600 mile charge. So that's a real game changer. And at the same time, the price is coming down. So you got two things moving in the right direction. I just saw a number the other day. I think it was by 2021, there's going to be 220 different models of electric vehicles sold in the U.S. So you've got all of the automobile manufacturers that are moving forward with the development of a variety of different electric vehicles. So I think that's moving forward. The infrastructure, utilities are looking at how we can develop and increase really the infrastructure, charging infrastructure. The thing now that a lot of people are thinking through is fast charging. Can I get a charge in 6 minutes, fully charged? If you do the numbers, that is a tremendous amount of power. That's going to require a lot of current and a lot of upgrades to the electrical infrastructure, but I think that's what customers are going to be demanding. So long term, I think it is also around heating and cooling. It is about converting some of the older industrial processes to using electricity so that you can not only become more efficient, but you can also increase the speed at which you produce the product and increase the overall utilization. So a lot of things happening when you go out beyond 10 years. So now let me turn to Kate. My one question, Kate, is the work that you're doing on carbon capture, utilization, and storage, I think is incredible. And as I said before, it has to move forward. It has to be an option, just like nuclear has to be an option, just like a variety of different renewables has got to make sure that that's still part of the overall portfolio of generation opportunities. Carbon capture, storage, and utilization has to also be there. When do you think we will have carbon capture and utilization that is economic and a viable solution globally for fossil plants, both coal and gas? Is it 10 years out? Is it 30 years out to where it's economic and competitive with the other generation options? Just make a projection.
I think it's no more than 10 years out.
More than 10.
No more than 10.
No more than, wow. All right. Now that is, you heard it here. That is a big deal. So.
Can I tell you why?
Yes. Please.
A lot of you have heard of the X Prize. And the X Prize is, for those of you that haven't, is a contest that's being run by a number of government parties in Canada and some partners internationally. And they were looking for the best usage for carbon. And so they have a test site in the US. And we co-own a unit, an 800 megawatt gas unit with NMAX just outside Calgary. And we've devoted our stack to it. And so they started off with 10 candidates, and they're now down to a short list of 5. Our carbon nanotubes are one of the 5. And all of these technologies are now to the stage where by 2020 they are just being tested for scale. So they have all been proven technically viable, and they have all been proven, or the products have been given values, and they have worked on partnerships for marketing them, etc. The test that happens between now and 2020 is just to prove that these technologies work at scale. I have every hope that all 5 of them will work at scale. And I'm not sure that I agree that this is, I think that we would plan, for example, there are ways to snap this technology on, as we have at our Shepherd plant in Calgary. So I'm not sure that the economics at the end of the day are going to really be an issue at all, assuming that the products produced have economic value. Developing the markets might be a tougher one, but to the extent that we are all strategically creating partnerships now, I think we'll have that nut cracked, and so I believe that Capital Power will build its very next natural gas unit, and we already have one permitted with carbon capture capabilities.
I love it. That's a bold projection. So we're all pulling for you, and keep us updated. We're definitely going to be following that. So we've got about, let's see here, 15 minutes left, and I want to ask Ty, Nigel, Terry. We heard a bold projection from Kate, and just take 30 seconds, a bold projection, and then we're going to turn it over to the audience. So get your projections ready, get your questions ready, and we'll finish with questions from the audience. So again, if nobody asks any questions, we're going to ask you. So who wants to go first on a bold projection? One of them. Nigel.
We'll have 50% of the national car fleet or vehicle fleet electric by 2030.
50%. Total vehicles.
Total vehicles.
How many autonomous?
I don't know if it really matters, but I haven't thought about that one.
Okay, that's okay.
I'm going to take a slightly different look on this. We all have prognostications on what's going to happen in the marketplace, but I think our business models, our businesses are changing as radically as are the solutions and technologies we're bringing into the market. And for us, this is meaningful. Today, about 5% of our earnings in the U.S. are tied directly to customers' choices. They opt to do one thing or they do another thing, and our earnings are tied to that instead of our investment in assets. I think that's going to triple in 3 years. And we'll be at 15 or 20% of our earnings based upon customers' choices.
I'll make a bold prediction that 10 years from now, the concept of electricity networks businesses and the whole network dynamic being a regulated monopoly type business will disappear altogether. It'll be an entirely free market as much of what we've been talking about here today opens up, and much like generation is at the moment, just a market-based commodity, that similarly the entire concept of supply to end users and their ability to share their own production of energy will just be a free and unregulated market.
Excellent. So a bold projection, 2. 1, we will solve the cybersecurity problem. Now, I don't know exactly how yet, but I think we're going to have to do that, and I think we'll get it solved. 2, I think artificial intelligence is going to have a significant impact on everything that we do. I think it's going to be very positive. It's going to be positive for the customer. It's going to be positive with how we produce electricity and how we deliver electricity. And I think it's going to make an incredible impact. And the main reason is computational power has increased significantly, and that allows us to solve these more difficult problems. And we've got access to a tremendous amount of data that we never had access to, and we're going to find out all kinds of things from that. So that's mine. All right. Now, turn to you. Yes, sir, David. It's good to see you, David. I haven't seen you in a while. Looks like you're doing great.
Outstanding panel. So I'm going to pick up on how Tom Kuhn started this discussion and ask a question relating to public policy. So all of you talked about transformative technologies and, really exciting stuff you talked about. But shouldn't there also be a transformative pricing model? Because you can have all of these technologies, but unless you have a way to recapture your costs, your investments, it's not going to work. And I think Nigel kind of touched on it a little bit when he was talking about wholesale and retail markets. Some suggest down the road we're going to be driven by transactive energy, transactive markets, peer-to-peer transactions. Whole different way that you've got to look at your product and how you price it. So I just like to hear a couple of views from the panel on that. And it is transformative. All these things that you talked about, the technologies are transformative, but the way that you price your product is also got to be transformative.
Transactive energy. Thoughts? May want to jump on that one? Or anybody in the audience, too. It doesn't... Okay.
Well, I'll go first. Look, I couldn't agree with you more. I think that was exactly where put in some better words. Thank you. Where I was heading with my point as well. Thank you. The reality is, and we talk about the rate and pace of change within our industry at the moment. The reality is we're still dealing with fundamentally a set of rules that were set decades ago at best, and were set when much of the technology that we are currently using, let alone that we're on the cusp of implementing next generations of, wasn't even a pipe dream. Without being too pejorative towards regulators, I think also the reality is they've got a bit of a crisis of faith going on, or existential crisis is probably a better way to put it, themselves. Because when you are a regulator, many things that arise usually appear to need some regulation. The reality is this transactive model, transactive pricing we're talking about at the moment, is going to require, I think, a degree of political and social momentum to come in behind it to really, in a blunt way, shift people's mindsets away from the traditional regulated model. I'm concerned that if we keep trying to do what we've done so far as an industry collectively, working with our regulators, we've got the was an old lady who swallowed a fly problem. We're going to keep trying to put regulation onto things, and eventually we're going to swallow the horse, and that's going to be to the detriment of our customers and the detriment of our industry. We've got to really take a completely different clean sheet mindset to what we currently regard as being the transactions, the regulations and the models around our industry.
Yeah, I think that's a great question and a great answer. This whole transactive energy concept, and we deliver energy. We pay for energy. We deliver capacity. And that whole discussion around energy and capacity and so on, it is going to force a discussion around, I think, more of this transactive energy. We've been kind of brainstorming that a lot at EPRI, and it is right on the leading edge of some of the discussions that we're having, and it's got to be addressed. So, Terry, what do you think?
Yeah, I mean, I'll just add that I think spot on. But I think that the heart of the regulatory model is going to have to shift as well, and that we can experiment with and try all kinds of different pricing schemes that support transactive energy or behavioral changes with customers. But to the degree that they all remain based on cost liquidation, it doesn't add up. I don't think. At least our regulators are pushing us to look at scenarios where, whether it be through unregulated activities or otherwise, we're looking at more value creation. And through value creation and possibly pricing for value versus pricing for cost, we actually see fundamentally different earning streams for the company. And so that's, I was similarly trying to refer to that. I think that's I think the underpinning shift that's going to occur in the industry. And it's hard to articulate and hard to describe, but I think it's going to be essential to actually seeing meaningful outcomes.
For me, the value of electricity is a lot more than the cost that I pay. And if you don't think so, just see how you feel when you can't charge your cell phone and how much you're willing to pay for that. So, Nigel, any thoughts?
Or just a couple. I think everyone else pretty well summarised it, but I think it is a challenge for the regulators. They, in many senses, there's this, how do they get, because they are being pushed by various other forces, affordability and that. So if you think about the wholesale market, inherently, they like those pro-competitive outcomes, but if the prices start to go up too much to enable new build to come on, new cleaner power stations to come into the system, they will be under pressure to push back on that. And then we've seen various examples of wholesale markets sort of implode or lead to quite negative outcomes. They also need to try to really work on pricing signals and being confident around it. The kilowatt hour model is just not going to work as we head forward. They know it, but trying to bring along their political masters is a challenge. We've all seen examples. Victoria was the classic one in Australia. Mass rollout of meters to lead to sort of time of use and other forms of quite clever pricing. Started it, abandoned it, with the heat came on, killed it dead. And we can't have too many examples of that. And I think, there is a transition of whether utilities, the core monopoly part ceases to be regulated or not. I think, it'd be interesting to think they might not be. But I think the challenge in the interim is how you evolve the traditional rate case, which is we put our rate cases forward, they're predicated on effectively this is the money we need to keep the service the same as today or improve the service, and this is what we're asking for to lower or improve cost to serve. The challenge with a lot of the new and exciting technology out there is it doesn't actually necessarily reduce the cost to serve. It might increase our costs, but it enables a group of third parties, not necessarily the entire customer base, to capture some really interesting and potentially quite valuable benefits. But how do you take that into the traditional rate case model? Because that benefit set isn't being socialised across everybody. It's possibly beneficial at a country-wide or economy-wide level, but it's very hard to make work. And you'd sit down and talk to various regulators globally, and they're all starting to think about it, but none of them really have an answer on how they quantify that yet and whether they're prepared to push the rules on it.
Excellent. So we have 4 minutes left. And so.
Just got 5 more extra, so you got 9 minutes.
9 minutes. Okay, in that case, because what I want to end with, and I'm going to go ahead and kind of give you guys a little bit of warning, is I want a kind of a 1 minute. We're going to ask, I'll get to your question here in a minute, but at the end, I want 1 minute to most on, we talked about bold projections, words of wisdom. So words of wisdom, looking out in the future, 1 minute. So we'll kind of end with that, and then I will end with my 1 minute words of wisdom as well. So let's go. Question.
Hello, everybody. Rafael, I run an advisory in energy. I wanted to bring a contribution to the global vision 2030. We have talked a lot about the big energy system, the power grids, but one of the elements that we could also look at is the energy saving side. And you mentioned artificial intelligence, but I think that the development of IoT and the capacity to have connected objects are considerably going to change the way objects that are using energy within buildings, within homes, within industry are going to interact with each other. We have seen recently developments of energy communities based on blockchain, but what will happen is that we will have sockets, projectors, air conditioning system being able to talk to each other, and there's a bulk of energy saving there that is going to help us further develop the power systems, but also reduce the emissions because we're going to be more efficient. So my projection is that we should be around 30%. By 2030, within 10 years, we could potentially lower at least by 10 to 15%, potentially 2050 by 30% the demand of energy, taking into account, this IoT, artificial intelligence, and also the fact that we're going to have new technologies regarding distributed energy. Today, we look at solar panels being only on the roof of buildings, but tomorrow with organic PV, these windows could be, generators of energy while being transparent. So there's a range of technology at local level that could be considered in our global framing. Thanks.
And I couldn't agree with you more. We will have, all devices will be intelligent. All devices will be able to share that information with their neighbor, and all of them will be able to self-optimize to improve their efficient use of energy. So I from lighting to projections to HVAC systems to your electric vehicle and everything, and that's the power of intelligent transformation. And I think that's where we're headed. So any comments from the panelists? Okay, let's go. We have one more, okay?
Good morning, Francis Bradley, Canadian Electricity Association. Michael, a really interesting panel, and I want to, note the magazine covers are really interesting as well. But the one thing that I didn't hear this morning, and the one thing that I didn't see on those panels, and maybe it's an answer as well to the question that you asked earlier about customers wanting to be able to recharge their vehicles in a matter of minutes instead of hours. Have we given up on hydrogen?
Good question. In fact, last week we had our board meeting and we talked about hydrogen, and hydrogen as a fuel, possibly even as a storage fuel with fuel cells, I think is absolutely a technology that we need to keep in play. But probably something that is in the 2040 to 2050 timeframe. I think we need to figure out new catalysts, new ways to separating H from O. They love each other too much. And as a result of that, it takes a lot of energy to separate it. But there are some advancements around high temperature nuclear reactors that can help do that, and also surplus of renewable energy. So I personally think it's something that we've got to keep in play and not lose that. Any thoughts here?
I'm advised, again as a dumb lawyer, that all of the new J-class machines that are currently being produced will co-fire up to 25% hydrogen today. And so another bold prediction from me would be that there won't be any new natural gas plants built beyond 2025 that aren't hydrogen capable. I would give just another shout out to ATCO. Dale is here. Give us a wave, Dale. I was recently hearing Nancy Southern, who is the CEO of the ATCO companies, talk about how they're planning potentially to repurpose their natural gas pipeline distribution system for hydrogen. And so there's a lot of good work being done there. It's going to come sooner than you think.
Yeah, that, in fact, we were talking last week at the repurposing gas line for hydrogen. I mean, right now, I think I heard you can co-blend up to about 15 or 20%. You know, that's a step. So yeah, I think it's a little further out there, but it is something that is going to be really, really important for the future. So let me, all right, so we have 4 minutes. All right, so words of wisdom, less than a minute on the future. Who wants to go first on this one? Nigel, you got it.
So look, I think it's where your starting position is really relevant to all of this, because we're all different. You know, Ty and myself, we sound vaguely similar because of our antipody and accents, but New Zealand and Australia are fundamentally different. You know, he puts an electric car on the road, and this is a good example. He puts an electric car on the road, it is grubbier than a 1980s V8 because it's powered by brown coal. I put an electric car on the road in New Zealand, it's a hydro-powered car. So I think starting position is really important for talking to your customers, really important for policymakers to understand that. And it's also understanding what are the problems you're trying to solve. In New Zealand's case, it's long-term. You know, if we're going to electrify it, we need to solve a multi-month seasonal storage issue. And lithium-ion isn't going to, frankly, help us. Lithium-ion is an intraday energy shifter. It shifts peak around, but doesn't create new energy to solve a multi. And being able to communicate those things are going to be really important.
Good. All right. Next.
I think we got to bring more people into the tent. Whether it be technology, we got to lean harder on partners who are experts in this area. We were talking about that earlier. Whether it be regulation, we got to lean harder on stakeholders who have a voice, or whether it be customers, we should listen to customers and see what it is that they truly want.
In a day when public policy follows public opinion, and public opinion is determined by sound bites, headlines, and 144 characters, it behooves us all to make sure that minds are kept open to whatever is the best possible solution. We need an all-of-the-above approach. We can't be picking and choosing. And the people in this room, I think, are the best ambassadors for that message, because although it may sound a little bit self-serving, you guys are the experts, so please educate people.
I suppose I'd echo fundamentally Terence's comments there. Don't think we know everything, and don't try and do it all ourselves. Whether that's thinking that we know what our customers want or what their problems are and how to best serve them, as opposed to actually going and finding out from them what they really want. The metering example that you used, Nigel, down there in Victoria is a classic example of losing the sensible public discourse with your customers. What could have been just a tremendously beneficial for society outcome ended up in the narrative sense being, people worried about the smart meter giving their cats cancer or something because it was put on the side of their house. Literally, that was one of the headlines. So don't try and do it all yourself with the technology either. Pick strategic partners. Not all of them will be winners, but pick them anyway. And one of the things that we're having great success with is keeping our engineers focused on working with our customers and doing what we do, and letting strategic partners bring into the discussion and bring into the solution suite what they do, because there's so much innovation going on across parallel industries to ours as well as intersecting ones. We really need to engage with them, let them do their stuff. I'll clean that up from my earlier version, and we stick to our stuff and integrate the two together.
Excellent. So I started this session and I mentioned that electricity plays a very special role in our energy portfolio. It's a very special, high-grade form of energy. Each of us plays a very important role in helping to ensure that this global form of energy becomes even more valuable for society. Safer, reliable, affordable, and cleaner. And as I look to the future, and I look at the leaders in this room, I look at folks like Lawrence, and what I see is a tremendous opportunity to make a global difference. And it's in this room. And so I want to say thanks to our panelists. I want to say thanks to everyone in this room for what you do to make a difference globally. It is critically important for society. Thank you very much. Lawrence, it's yours.
Thanks, Mike.